All right, guys, you'll have to excuse the voice here, but I'm going to try to get you through this review sheet to help you for that quiz on Monday. So the first set of problems here, just like we did the first couple days this week, just combine your variables, right? So you have a 3 and then you got 2y, so that turns into 3y squared. Here, um, the one kind of tricky thing here is that 2 is all by itself. It looks like everything else, u to the first, v to the first, v to the third, all go to the denominator because the negative exponents. And now combine those v's. So you have v to the fourth. So 2 over u v to the fourth. The next problem, you have that 4 times 2, so you can go ahead and combine um, those values. You have a u, a v to the third in the numerator, and then you have v to the first in the bottom in the denominator. And so if you cancel v's, you're left with 2 v's in the top, nothing in the bottom. So we'll just leave it as is. Here, 2 times 2 is 4. We still have a y squared and an x third at the top. And then you got an x to the first and a y to the first in the denominator. If we were to combine like or do some canceling, we're going to be left with 2x's and 1y in the numerator and nothing in the denominator, which means we're left with just 4x squared y. Here we're using our power to power rule. Make sure you distribute that third power to all three pieces. We have 4 to the third, b to the third, a to the 12th. 4 to the third is 64. So go ahead and do that. So 64, b to the third, a to the 12th. Um, if you're all about some alphabetical order, feel free to switch those. But these say the exact same thing. Here, distribute that negative second power, so that turns into x to the 8th, y to the negative 4th. And since y has a negative 4, it's going to go into the denominator. X to the 8th stays in the numerator because it's a positive value. Okay, it's starting to get a little bit more complicated. The x to the 4th, the z to the 4th, and the 3 all stay in the numerator. You're still going to keep that z to the 4th in the denominator, but we're going to move an x to the 3rd and a y squared to the numerator. Now we start cleaning some of this stuff up. We have 3, there are now 7 x's, there are 2 y's, z to the 4th. There are 4 z's in both the numerator and denominator, which means they're all going to cancel, leaving with 3x to the 7th, y squared. Here the 4's will cancel right away. Um, that m to the 4th, so you have p m to the 4th in the denominator, that's coming right over. But then the other m to the 4th and the p to the 3rd are going to come down. Well, now I'm left with nothing in the numerator, which means really there's a 1 there. Now if I put everything together, I end up with 8 m's and 4 p's. So when everything cancels, remember there's a 1 there. 9 and 10 start to get a little bit crazier, but again, this negative 3 is on the outside of the parentheses, so everything gets the negative 3, even the things in the denominator. So we have 2 to the negative 3rd, x to the 3rd, y to the negative 6th, 2 to the negative 3rd, y to the negative 9th, z to the negative 9th. So take your time. Anything with negative exponents, let's switch places. Um, if you want to think about it, it looks like this 2 to the third, negative third, 2 to the negative third. Those are just going to switch places, and they're going to end up canceling anyway. But we'll do it 2 to the third. They're going to switch places. This y to the ninth, negative ninth, it's going to go up. X to the third stays put, but you got a y to the ninth joining it, and a z to the ninth. This y to the sixth is going to come to the bottom. So now we've got 8, x to the third, y to the ninth, z to the ninth. 2 to the third is 8, y to the sixth. As you can see, there's y's in the numerator and denominator. If we cancel, we'd be left with 3 y's in the numerator. We still have this 8. Those 8's are going to cancel, which means I'm left with x to the third, y to the third, z to the ninth over 1. And I can just write that as x to the third, y to the third, z to the ninth. When 1's in the denominator, you don't have to rewrite it. But you saw number 8, if 1's in the numerator, you do have to write it. Number 10. Number 10, again, everything's going to get the negative 2. Send the negative 2 through everything. So that turns into p to the 6th, q to the negative 8th, r to the negative 4th, p to the negative 2, q to the negative 8, r to the negative 6. Now start moving pieces around. That first p to the 6th is staying put. That q to the negative 8th, that's coming to the bottom. This r to the 4th is going to come to the bottom. This p squared to the top, q to the 8th to the top, r to the 6th is coming up to the top. So here we go. Now we got p to the 8th, q to the 8th, r to the 6th, over q to the 8th, r to the 4th. Here, all the q's are going to cancel with my r's. All of them are going to be gone from the bottom. I'm going to be left with 2 in the top. "11, 12, 13, 14, these things look big and scary, but if you do it a step at a time, you're going to be okay. Now, the first thing, that negative 4 is going to go to everything inside the parentheses, so let's take care of that first. So 2k h squared, then we have 2 to the negative 4th, h to the 12th, j to the 4th, k to the 12th, over h to the negative 4th, j to the 3rd, k to the 2nd. I suggest now moving any negative exponents. So 2kh squared, you still have the h to the 12th, j to the 4th, and the k to the 12th in the numerator. And we're going to move j to the 3rd and k squared. Excuse me, those are going to stay put in the denominator. But what we need to do is we need to move, we've got a 2 to the negative 4th that needs to come down into the denominator. So I'll put it first. And then this h to the negative 4th has to move up. So it's going to move up to the numerator. Excuse me, when that 2 came to the bottom, we got rid of the negative. So that's 2 to the 4th. So here we go, we got 2. Let's start combining. So there's 1 plus another 12k, so that's k to the 13th. There's 2 h's, 12 h's, plus another 4, so that's 18 h's, 4 j's. 2 to the 4th is 16. J to the 3rd, k to the 3rd. The 2 and the 16, that'll be 1 over 8. When I look at the k's, I put those together, I'll be left with 10 k's in the top, 1 j, there's h to the 18th. Right, you put those j's together, there's no j's left, so there's your final answer. Same thing with 12, everything's going to give that negative 4. Send that all the way through all the pieces. C to the negative 8th, 2 to the negative 4th, x to the 4th, y to the negative 12th, and then z 16, 2 to the negative 4th, x to the negative 4th, y to the negative 12th. So what you see there, I just kind of, I stopped it for just a moment to do all the switching. So anywhere there's a negative exponent, right, we just switch places. So 2 to the 4th is 16, and I'll have 8 x's, 12 y's, and 16 z's in the numerator. 2 to the 4th is 16, I've got 12 y's, I've got 12 x's, 20 y's, and 8 z's. The 16's are going to cancel. Now it's just, we have 4 x's left in the denominator, but then we'll have 8 y's left, and there'll be 8 z's left in the numerator. Make sure that's not a negative. All right. Don't be intimidated by these bigger ones. It's just a little bit more work, and you just got to do it one step at a time. Here, let's take care of this situation first and distribute that fourth power. So I'm just going to rewrite the numerator as is. And then let me get this in here, into the 8th, p to the 16th. Now let's move pieces around that need to move. So the 2, the n, the m squared, they stay put. The p to the negative 3rd is going to come down. The n stays put. M to the 1st is coming down, and then that p to the 3rd stays put. Into the 8th and p to the 16th stay put. So now just start putting as much as you can together. So now we have 2n squared, m squared, p to the 3rd. I've now got 19 p's, 1m, and 8 ends. So when I start thinking about canceling stuff out, the 2 is going to stay put. In terms of ends, there's going to be 6 ends left in the denominator. 1 m will be left, and then it looks like 16 p's will be left in the denominator. Here, take care of this, distributing that first. So we end up with x squared y to the 4th z to the 6th over 2x squared y to the negative 2 to x to the negative 3 y to the negative 3 z squared. Now let's take care of those negative exponents. So x squared y to the 4th z to the 6th, everything staying put. Let's start picking our way through the denominator. The 2 stays put. The x squared stays put. The y squared has to move up. The 2 stays put. The x to the 3rd, the y to the 3rd comes up. The z squared stays put. Now let's start combining what we can combine. There are now 5 x's in the numerator. There's 4 plus 2 plus another 3, so that's 9 y's in the numerator and 6 z's. The 2 times 2 is 4, x squared, z squared. So it's starting to clean up a little bit. Now what can we cancel? With the x's, there's going to be 3 left in the numerator. Nothing to cancel with the y's. So there's going to be 4 z's left. Everything in the denominator is gone except for the 4, so that's what we put. All right, and then the final page of this, solving those equations, getting those like bases. So is there a way to get 64 into a base of 4? Sure enough, there is. This is 4 to the 3rd. So we have 4 to the 3rd, and then 4 to 3x minus 2. Kind of ignore those now. So 3x minus 2 equals 3. Add 2 to both sides. So 3x equals 5. Divide by 3. X equals 5/3. Here, 6 squared. You still have that negative v on the outside. 6 to the negative 3. So we have negative 2v equals 3. Divide both sides by negative 2. So v equals negative 3 halves. Number 17. The work's basically already been done for us. We don't have to move anything. We just have to do 2n equals 1 minus 2n. So let's move the 2n over here. Add 2n to both sides. And with 4n equals 1. Divide both sides by 4, so n equals 1/4. Here we got to change this 16. That's 4 squared. We still have that negative 3x outside the parentheses. So now that we have the same base, just put the exponents equal. So 3x minus 3. Multiply these using our power to power rule. That's negative 6x. So I'm going to move the 3x over. So I'm left with negative 3 equals negative 9x. Divide both sides by negative 9. You're left with a fraction. That's 1/3 equals x. Negative over negative is a positive, remember. 2 more problems here. Number 19 is already set up for us. We already have the same base. So we can pretty much ignore the 4's. Just do 3x plus 1 equals negative 3x. So subtract 3x from both sides. With 1 equals negative 6x. Divide both sides by negative 6. So negative 1/6 equals x. Here, there's no way to get 64, right? 16 squared equals 256. So there's no way to get 64 to be a 16. So this is one of those we're going to have to break it down even farther. Let's break this down to 4. This will be 4 squared to the 1 minus x. And 64 is 4 to the 3rd. So here's one where you got to actually work on both sides. Now that we got the same base, ignore this stuff. So we end up with 2 times 1 minus x equals 3. Distribute. 2 minus 2x equals 3. Subtract 2 from both sides. So negative 2x equals 1. Divide by negative 2. So x equals negative 1/2. So there'll be a little bit of each of those on your quiz on Monday.